Okay, today we're going to talk about evaluating exponents. Now, bases, powers, and exponents have been part of your math classes for a few years now, and today we're going to take the time to review some of the exponent rules using variables. This is going to take a little bit longer today because we have a lot to review. Let's start with multiplying with exponents. You know the basics of exponents. 3 to the second power means I'm multiplying two 3's together. 5 to the third means I'm multiplying three 5's together, and so on. Just a quick review here. 3 to the second power, the whole thing together is known as a power. 3 is the base, and 2 is the exponent. 5 to the third is a power, 5 is the base, 3 is the exponent, just so we know what we're talking about. Now we're going to talk about multiplying powers, and in these powers we have common bases. X to the third and x to the fourth both have a base of x, and each base has its own individual exponent. That's an important piece to pay attention to when we review this first section. To make this a little easier to visualize and to understand why we do what we do, I'm going to take the time to actually draw this out. I have x times x times x for x to the third power, and I did the same for x to the fourth power. Since the whole thing is being multiplied together, don't I end up with x to the seventh power? Of course. And what would I do with a 3 and a 4 to get the 7? Yeah, let's take a look at the next one. Here I have 3 different powers being multiplied together, all with a common base of y. And again, I'm going to take the time to draw it out. I have y squared times y to the fifth times y to the fourth. And if I look at the whole big problem, all of those y's being multiplied together, I find that I have 11 y's being multiplied together, so I write y to the 11th. Be careful, if I wrote 11y, that would indicate that these y's are being added together. When I multiply variables together, I get an exponent or a power. Again, just taking a look, 2 plus 5 gives me 7, and 7 plus 4 is where I'm getting the 11 for the y to the 11th power. So down here, let's try this first of all without taking the time to write it out. I have 6 m's being multiplied to 4 more m's, so far we have 10 m's being multiplied together. One more takes us up to 11, and 2 more gives us m to the 13th power. I can take the time to write it out if that makes it easier, but I'll end up with m to the 13th power. If I multiply powers that don't necessarily share the same base, I need to look for powers that have the same base. Here I have x to the third times y to the fourth times x to the fourth times y to the third. I have 2 sections of x's and 2 sections of y's. But remember, in multiplication, order doesn't matter. 2 times 3 is the same as 3 times 2. So again, order doesn't matter in multiplication. I can take all 7 x's and multiply those together all at the same time, and all 7 y's and multiply those together. And I end up with x to the 7th times y to the 7th. In my second example, I only have 2 powers with matching bases, r to the 2nd and r to the 4th. I can combine those into r to the 6th, and then the j to the 12th and the w to the 5th simply get included in my simplified exponent or power. In the third example, I don't have any powers with matching bases. There's absolutely nothing I can do to simplify that power. Sometimes there will be coefficients involved, like the coefficient of 6 on 6m to the third, and the coefficient of 5 on 5m to the second. In cases like this, if everything's being multiplied together, I can go ahead and multiply the coefficients. 6 times 5 gives me 30, and then m to the third times m squared gives me m to the fifth power. In the second example, I have 3 coefficients. 2 times 4 is 8, times by another 3 gives me 24. Then I have x to the third and x squared, giving me x to the fifth, and then y to the seventh is going to be included. So 24x to the fifth, y to the seventh. Now on to some not so basic basics. Sometimes you have powers that are being taken to another power, right? I have one base, say this x, that has 2 powers or 2 exponents being applied to it. I have x to the second to the fourth power and y to the third to the fourth power. This one looks a little different, and I'm going to take the time to draw it out so we understand how to simplify. The 4 on the outside, or the exponent of 4 on the outside of our parentheses, means that we have 4 different sets of parentheses being multiplied together. In each set of parentheses, I have an x squared and a y to the third, so 2 x's being multiplied together and 3 y's. If I draw that out, I can see that I have 2, 4, 6, 8 x's, and I have 3, 6, 9, 12 y's. So all in all, I'm going to have x to the 8th and y to the 12th. How would I get an 8 from the 2 and the 4? And how would I get a 12 from the 3 and the 4? In this case, wouldn't we multiply the exponents together? One base with 2 exponents means that to simplify this quickly, I would multiply their exponents together. In my second example, the exponent of 2 on the outside means that I have 2 sets of parentheses being multiplied together. So I'm going to end up with 6 m's, I'm going to end up with 4 k's, and I'm going to end up with 8 d's. So m to the 6th, k to the 4th, d to the 8th, and we're simplified. Again, if I have an exponent outside the parentheses, I can kind of distribute and multiply that to every exponent inside the parentheses. If you take the time to think about it and write it out, it's going to make simplifying powers so much easier, especially if you are someone who has struggled with powers in the past. Let's try 2 more before we go on to our next review topic, and this is where I've thrown some numbers in, right, some coefficients. In the first example, the coefficient of 2 is inside the parentheses. So I have 3 sets of this parenthesis. I have 3 2's being multiplied together, 3 sets of x to the third, and so on. So when I do this, I have 2 times 2 times 2, and that's going to give me 8. Then I have 3 sets of x to the third, so I have 3, 6, 9 x's, so x to the 9th. Y to the 6th I have 3 sets of, so 6, 12, 18 of the y's. And z to the first, I only have 3 of those, so I have z to the third power. And we're simplified. Be careful, one of the most common mistakes that students make in this situation is multiplying the coefficient times the exponent. This is not 2 times 3, it's 2 to the third power. Be a little careful with that. In the second example, our coefficient of 3 is not inside the parentheses. It's only the parentheses that get written out 4 times. Let me show you what that looks like. The 3 stays out front, and then I have 4 sets of parentheses. that means the 3 will stand alone. And I have 3, 6, 9, 12 D's. I have 2, 4, 6, 8 E's. And I have 3, 6, 9, 12 F's. I end up with 3 times D to the 12th, E to the 8th, F to the 12th. Let's move on to the quotient property with exponents. And again, quotient is what you get when you divide. What happens when you have a fraction that has the same numerator and denominator? Don't all of these fractions reduce to 1? Is it any different when I have variables involved? How about y over y, or a over a, or x over x? Those reduce to 1 as well, and that's going to help us in quotient property. If I have 3 to the 4th over 3 to the 2nd, I'm going to take just a minute to draw that out. Here's a disclaimer before I do this next step. This only applies when everything in my numerator is being multiplied together and everything in the denominator is being multiplied. If I have any addition or subtraction involved, this next step does not apply. So if we do have all multiplication in the numerator and denominator, I can take every 3 over 3 and reduce it to 1. Multiplying by 1 is not going to change anything. In the numerator, now I have 1 times 1 times 3 times 3, and that's going to give me 9. In the denominator, I have 1 times 1. This new fraction becomes 9 over 1, which simplifies to 9. In my second example, I put some negative numbers because we need to be a little careful when we use negative numbers to a power. Every 4 is going to be negative, and in these cases it's going to be really helpful for you to keep using parentheses every time you write a negative number. Again, negative 4 over negative 4 can reduce to 1, and I'm left with negative 4 times negative 4 gives me 16, times another negative 4 gives me negative 64. Now let's look at that with variables. X to the 5th over x to the 3rd, again I'm going to take the time to write it out. I have only multiplication in my numerator and denominator, so I can reduce all my x's over x's to 1's. And I'm only left with x squared. In the second fraction though, our fraction has been inverted. When I take the time to write it out and reduce, notice that in the numerator I'm left with 1 times 1 times 1, which is 1. And in the denominator I'm only left with x times x, which is x squared. This fraction reduces to 1 over x squared. My leftover x's are in the denominator, and I need to keep writing them as a denominator. Be a little careful because, again, a lot of students mistake these two problems and think that they have the same answer. If we have coefficients involved, we can reduce those coefficients just like we do any other fraction. 15 over 10 becomes 3 halves. When I reduce all of my x's and y's, if you can look through this mess, I have 1 x in the numerator left and 3 y's in the numerator left. So my numerator becomes 3x y to the 3rd, and the only thing left in our denominator is 2. In the second fraction, negative 2 over 6 reduces to negative 1/3. I'm going to have 1m reduce to 1, and I'm going to be left with m squared in the numerator. I'm going to have 2 e's reduce out of the picture, and I'm going to be left with e to the 3rd in the denominator. Feel free to write that out and reduce it by hand. The only thing I'm going to say about this is that this is going to stay negative, of course, but the 1m to the second in my numerator doesn't need that coefficient of 1 to be simplified. Just a bit of caution, like I said before. 1x, make sure you simplify that to x. X over 1 simplifies to x, and x to the first power simplifies to x. Make sure that everything is good and simplified. But 1 over x cannot be simplified to x. Common rookie mistake. Just like 1/3 is not the same as 3. Now let's go on to negative exponents. Here I have an example. I have it written out, but what I want you to notice is when I get my simplified power of m to the third, what I did was subtracted my exponents. If I have a quotient, I can actually subtract exponents, numerator over denominator. If I invert that fraction, now I get 2 minus 5, and I get 1 over m to the third. But when I subtract those exponents, 2 minus 5, I actually get an exponent of -3. M to the -3rd power is what I get when I subtract, but 1 over m to the third is what I get when I reduce. Well, the definition of a negative exponent is exactly that. If I have x to a negative exponent, like x to the -3rd, I can actually make that in reciprocal, right? I can reciprocal that fraction, and when I bring that x to the -3rd to the denominator, my exponent becomes positive or changes sign. Same thing can happen the other way. If I have a negative exponent in my denominator, I can move that power to the numerator and my exponent will change sign, in this case making it positive. Very often, or I should say pretty much always, you'll be asked to make sure that you only have positive exponents in your answers. So we need to learn to move the negative exponents to make them positive. If I have 2 times x to the -4th, it's only x that's getting taken to the power. 2 doesn't have a power other than 1 on it. So the 2 stays where it is in the numerator, and the x to the -4th gets taken to a denominator to become x to the +4th power. In my second example, everything's okay except for the x to the -2 power. The x has a negative power, and that's not okay. So I'm going to bring that to the numerator and make that a positive power. Again, the only part that moves is the power that has a negative exponent. Here we have a fraction to reduce, and we want to make sure that everything ends up as a positive exponent. First of all, I have 2 powers that are negative. So I'm going to move the a to the -3rd to the denominator, and I'm going to move b to the -7th to the numerator. Then 4 over 6, of course, is going to reduce to 2/3. If I bring this a to the -3rd downstairs and make it a to the +3rd, that's going to get combined with the a to the 5th. The b to the -7th, when it comes to the numerator, is going to become b to the +7th, and it's going to get combined with a b to the 2nd. I'm going to have a to the 8th in the denominator and b to the 9th in the numerator, and my final fraction is going to look like this. Take the time to write it out if that's helpful. Lastly, let's talk about zero exponents. Remember in our quotient property how we subtracted the powers, or the exponents? Well, x to the fourth over x to the fourth, I can write that as x to the 4 minus 4 power, and I get x to the 0 power. But isn't x to the fourth over x to the fourth, if I reduce that fraction, doesn't it become 1? Of course. This shows the reason that anything with an exponent of 0 is equal to 1. So if I have 3 to the 0 power, or y to the second all to the 0 power, or this nasty looking power all to the 0 power, everything here is equal to 1. Anything, no matter what it is, when taken to the 0 power is equal to 1. Just a caution, if you have a negative in front of your fraction, just like before when we had the 3 that didn't get taken to the power, same thing here. The negative is not part of the power. The negative stays. Everything else goes to 1, but I'm going to end up with a negative 1. Watch for items outside the parentheses. Now, I'm going to give you guys a task. I'm going to ask you to try to simplify this power. Pause the video so you have time to do it, and then restart the video when you're ready to move on. You should get 3y to the 5th over 5x to the 6th. If you got it, great. If not, go back and review some of the properties of exponents again. Let's try another one. Pause the video so you have time. Did you get 1 over 16 d e to the 8th? If so, congratulations, you're doing great. Let's try one last example. Remember to pause the video so you can have enough time. This one reduces to 4x to the 5th over 3y to the 7th. I hope this video's been helpful. Thank you for taking so long to review exponents with me. And for now, I'm going to wish you a great day, and I'll see you next time.